One pigeon seeing another behaving in a particular way would have an opportunity to imitate, and to our surprise that happened.
In one experiment, they taught a bird on the left side of a double chamber to peck at a ping pong ball by reinforcing the behavior with food. A pigeon in the right side of the chamber had never been involved in laboratory experiments and had never eaten from an automatic food dispenser. When placed in the chamber alone, it did not peck the ball. When it could observe a bird in the left-hand side of the chamber pecking the ball, however, it began spontaneously pecking the ball and continued to do so during several daily sessions. Furthermore, it continued to peck at a low rate even after the conditioned bird was removed, and looked repeatedly in the direction of the absent bird as it did so. After getting the same result with other birds and other behaviors, Epstein and Skinner began again to look at some of the more mysterious sources of novel behavior. Social scientists have been interested in something called the self-concept for decades. Since the late 1950s, psychologists have used a child's behavior towards its own reflection as an index of the self-concept. It was said to appear in stages. In the late 1960s, an objective test was devised that was said to indicate when a child had crossed the threshold and was now aware of its own body. Some rouge was smeared on a young child's forehead, and the child was encouraged by its mother to look at its reflection. If the child touched the rouge spot, it was said to have an awareness of itself. This behavior was also said to indicate that the child had a self-concept.
The word is used as if it referred to a thing, which it does not. Some psychologists go so far as to say that it is a thing inside of you which grows. Second, this kind of concept, as far as I'm concerned, just obscures the search for the controlling variables of the behavior it is said to produce. That is, it doesn't tell you what the real causes are, and it keeps you from looking at them. And third, self-concept is really very little more than a description of what people do, and what children do, and what some chimps do. And it is then mistakenly used to explain the behavior that you see. The critical question is, how do you explain the behavior of a child when it is in front of a mirror and it uses the mirror to find something on its body, a spot, that it cannot see directly? And what we did was try to guess what kind of experiences had allowed the child to achieve that. And it turned out to be quite difficult to come up with those. And finally, over a period of about a year, I think, we stumbled onto two repertoires that did seem to be the correct ones.
Epstein and Skinner, with colleague Robert Lanza, spent 10 days establishing those two repertoires in a pigeon. First, without a mirror present, they taught a bird to scan its body for blue stick-on dots and to peck them. Dots were placed one at a time on virtually every part of the bird's body that it could see. They thus provided a repertoire of pecking itself, something the bird doesn't ordinarily do. Second, they trained it to make use of a mirrored space. It received food for facing a mirror and then turning to peck the place on the wall behind it where a blue dot had been briefly flashed. Dots were never placed on its body with the mirror present. Finally, they conducted the following test. A blue dot was placed on the pigeon's breast under a white bib. When the bird stood fully upright, the dot was visible to others, but the bib made it invisible to the pigeon, because when it bowed its head even slightly, the bib covered the dot. In a control condition, the pigeon was placed in its chamber with the mirror covered. If it could see the dot or locate it using tactile cues, it could peck it, but none of the three birds tested did so. When the mirror in the right side of the chamber was uncovered, however, the pigeon standing fully erect could see the blue dot in the reflection. At this point, each pigeon began bobbing and pecking repeatedly at the place on the bib which corresponded to the position of the blue dot. No food was presented during this test, and the bird had never before been exposed to a mirror when a dot was on its body.
As I say, there are three possible conclusions. The first is our pigeons have a self-concept, and I don't think very many people are going to go for that one. I hope not. And the second is that the mirror test is simply a bad test of self-awareness, and many psychologists who have a vested interest in this test will object to that, but many psychologists are going to be in favor of that conclusion. And a third conclusion, which is I think clearly where we stand, is that the concept is simply not a useful scientific category.
Well, what we did was to take what was said to be an example of the behavior which showed a self-concept. We were able to set it up in a pigeon by quite explicit analysis of the contingencies, and that is all. I think we attribute the behavior to what we know to have caused it rather than to a self-concept. Now, if someone wants to say, but that's not a good measure of a self-concept, we can simply say, give us another one, and we'll do that.
How far can this type of analysis go in explaining complex behavior? Could it deal with behaviors for which we reserve such terms as inspiration, creativity, logic, or genius? In 1917, a German psychologist named Wolfgang Köhler, isolated on the island of Tenerife by the war, observed some extraordinary problem-solving behavior by a number of chimpanzees, and his observations have been the subject of debate among psychologists for over 60 years. He arranged problems for them to solve and found that very often they came up with solutions very much as humans do. In one situation, he placed bananas out of reach in a cage in which there were several chimpanzees. At first, the chimps tried to get at the bananas by jumping. In another part of the cage, Köhler placed a small wooden box. After about 5 minutes, one of the chimps, named Sultan, clumsily moved the box over toward the bananas, climbed on the box, and, jumping with all his might, managed to pull down the bananas. How did Köhler explain this behavior?
Well, I don't think he explained it at all. He attributed it to something he called insight, which he insisted was beyond any ordinary explanation of behavior. And of course, in his day, there was not very much available by way of a science, and he couldn't possibly be right that at the time there was no way of explaining the behavior with the science available. But today is quite a different story, and simply to say the chimp showed insight is to tell us nothing.
In the 1940s, there was a psychologist named Birch who took some of the Köhler kinds of observations and showed that chimps who did not have certain experiences could not solve these problems. So he was showing how important these experiences were. Now, if we were going to try to test an environmental account of the solution to the box and banana problem, what we would do is we would make some guesses about what kinds of experiences were relevant to the solution of the problem, just like we did in the self-concept, the so-called self-concept experiment. It seems pretty clear that a chimp, or a child for that matter, who solves this problem has had a long history of reinforcement for pushing things around. It seems clear that a chimp or child has had a long history of climbing on things, and particularly climbing on things to get other things. A pigeon would be a good candidate to test this kind of account because, first of all, pigeons do not normally push things around because they don't have the limbs. And second, they don't normally climb on things because they can fly. So what you would want to do here is provide a pigeon with each of those repertoires. That is, through techniques of conditioning, get it to push things around, get it to climb on a box, say, and peck a little toy banana that's out of reach. Then finally, you would place it in a test situation in which there's this little toy banana, and there's a history of reinforcement for pecking this banana, and somewhere else in the chamber there's a little box. The result you would want is the following. You would want it to look pensive somehow or other. You'd want it to walk around in apparent confusion. You'd want it to look up at the banana, look over at the box, stretch up toward the banana, look back and forth between the two, and so on. And then at some point, rather suddenly, move the box toward the banana, and as it's doing so, look up at the banana. Sight the banana. Finally get it in about the right place, climb, and peck the banana. If we could get that kind of result, we could offer a fairly convincing account of how some history of conditioning contributes to success in this problem.
What we've done in the whole Columban simulation project is to show that by exploiting what we know about contingencies of reinforcement, we have produced extremely complex behavior which would ordinarily be attributed to higher mental processes of one sort or another. That, I think, is it. And I believe that we should then stop talking about the higher mental processes and look instead at the contingencies of reinforcement which are responsible for the behavior as we have demonstrated.
The accounts we're giving are not the whole story, and that's perfectly clear to us. For one thing, genes obviously play an important role in what we're observing here, and it's critical that one learn more and more about the role that genes play in the acquisition of complex behavior. For example, language, if genes are important there. Also, we don't really know what's going on inside the organism when these very interesting things are happening. When repertoires are coming together or whatever, there's obviously some very important behavior going on inside, and it's going to take a very sophisticated neurophysiology to tell us what is going on inside, and that's got to be done. Also, there are possible dangers in extrapolating from animal data to humans, and you always have to keep that in mind when you're drawing conclusions from this work. What I'd like to see someday is a kind of interdisciplinary approach to the study of complex behavior. You're only going to be able to give complete accounts of the kinds of behaviors we've looked at by knowing something about genes, about the nervous system, and obviously about environmental histories. But you've really got to know everything someday. There's got to be a synthesis, a grand synthesis of information, as there was, for example, in evolutionary theory in the 1930s. A synthesis of this sort is obviously a long way off, but I think work in this direction is worth pursuing, and it's certainly preferable to the highly speculative, mentalistic accounts that are currently what many psychologists offer.